In this video, we're going to continue working on the properties of logarithm. To start off, what we see right now is the list of common logarithm. So a common logarithm is simply the base 10 logarithm. And we covered last time that whenever you see a notation in which the base is missing, it's understood to be 10. Let's say you have a logarithm of x, and you don't see any base in it, it's understood that the base is 10. And when the base is 10, it's called common logarithm because it's very easy to calculate. All right, so let's get all the values of this common logarithm here, and these are all powers of 10. Okay, so the base is 10. I'm going to write down the base 10. So basically, the idea here is to find the number or the exponent to raise that base 10 to equal 1. Okay, so what I did is just converting this log equation to its exponential equivalent. So 10 raised to what? Give you 1. So that's 0. Okay. So logarithm of 1 is 0. What about logarithm of 10? So the logarithm of 10, again, this is base 10. So what is 10 raised to give you this number 10 over here? So we know it's 1. Okay. So the logarithm of 10 is 1. How about logarithm of 100? So the logarithm to base 10 of 100 is equal to what? So what do we raise this base 10 to give us this 100? So that's a 2. 10 squared is going to be 100. Okay, here we have base 10 raised to what? Give us 1000. So we know it's 3. And then here we have 10 raised to what? That equals 10,000. That's a 4. Okay, so let me clear the space and write down the cleaner version of our list of common logarithm. So we got log of 1 equals 0, and then log of 10 equals 1. Okay, log of 100 is equal to 2. Then log of 1000 is equal to 3. So one pattern that's obvious here is the number of zeros is the value of the logarithm. So here we don't have any 0. There's no 0, that's why we have here. How many zeros do we have here? 1, okay? How many zeros do we have in this number? We have 2 zeros. So the number of zeros is the value of the logarithm. Okay, so this is the list of our common log. Now there's a formula that also we can use. Let's say you're asked to evaluate logarithm of x to a certain base b. You can calculate that maybe with the use of your calculator using this formula. You get the logarithm of x divided by, divided by the logarithm of b. Okay, let's say you have this number here. What is logarithm of 100? I'm going to show the base here, which is 10. If I use this formula, this is logarithm of 100 divided by logarithm of 10. Okay, so we know that logarithm of 100, okay, is 2. What is logarithm of 10? Logarithm of 10 is 1. So we have logarithm of 100, which is 2. Okay, so you can use this formula also to evaluate logarithm. Okay, now the main three properties of logarithm, okay. Number one, if you get the logarithm of the product of two numbers, say logarithm of x times y, this is using the multiplication, okay, so we have x times y. This is equivalent to logarithm of the number x plus the logarithm of the other number y. So what happened here is the operation times is now converted to addition. So we know addition is easier. So the logarithm of xy is the same as logarithm of x plus log y, which means if we have to get, say, logarithm of 10 times 100, okay, say 1000, that's equivalent to just getting the logarithm of 10 and then add it to the logarithm of 1000. Okay, we know from the previous example that logarithm of 10 is 1 plus the logarithm of 1000 is 3. So this is a 4. Will that be equal to, okay, what is this here? That's the logarithm of, okay, 10 times 1000 is 10,000. And then the logarithm of 10,000 is 4, okay? So that's correct. Now the second property of logarithm, okay, there are three of them. Okay, number two is the logarithm of the quotient. Say you get the logarithm of x divided by y. So from number one, we have logarithm of the product, and then it becomes the sum of the logarithm of the x and y. Now, with that, we can say that the logarithm of the quotient will be equal to what? The logarithm of x minus the logarithm of y. Example, let's say we have, again, 1000 divided by 10. So if we have to follow this pattern here, or formula, it's equivalent to logarithm of 1000 minus logarithm of 10. Okay, again, logarithm of 1000 is 3, minus log 10 is 1, and 3 minus 1 is 2. Okay, let's see if we get 2 here. 1000 over 10 is 100. And what is log 100? It's 2. Okay, so that's correct. Now, the third and last property is the logarithm of x raised to n. So we have this exponent n, and we can convert this format to simply multiply the n to the logarithm of x. Okay. In other words, if we have to get the logarithm of, say, 10 to the fourth power, we can rewrite this as 4 times log of 10. Okay, so that's 4. Now log of 10 is 1. So this is 4, which is the same number we're going to get if we simplify this left side here, because log of 10 to the fourth is log of 10,000. Yeah, with the 4 zeros here, right? And then log of 10,000 is going to be 4. Right, let's see, we can take some more couple of examples here. Let's say we have log of 1. We know log of 1 is 0. Okay, by calculator or log table, I'm gonna give it to you. Log of 2 is 0.3010. Okay. Now log 3, also by calculator or by log table, is 0.4770. Okay, then we're going to get log 4, okay, using the properties of log. Okay, log 5 by calculator is 0.6990. Okay, and see how we're gonna get log 6. And then log 7 again by calculator is 0.8485. Okay, so how do we get log 4? Now we have this property. I mentioned that log of xy is log x plus log y. Now we know that log of 4 is log of 2 times 2. So we can rewrite this as log 2 plus another log 2. Now we have log 2 here, which is 0.3010, okay, plus another 0.3010. So that is going to be 0.6020. That will be our log 4, okay, 6020, and you can verify that using your calculator. Log 4 is going to be that number. Okay, how about, how do we get log of 6? Okay, so log of 6 is going to be what? It's going to be log of 2 times 3, which is log 2 plus log 3. And log 2 is 0.3010 and log 3 is 0.4770. So the sum of those two numbers will be our log 6, which is 0, 8, 7, and 7. Okay, so that's how you're gonna get the rest of the numbers, like log of 9. So let's say how you get log of 9. We can get log of 9 two ways. Either we express this as log of 3 times 3, or you can express 9 also as log of 3 squared. If we use this log of 3 squared, then we can use the third property, because this is equivalent to what? 2 times log of 3. Okay, so that's 2 times log of 3, which is 0.4770. Okay, so that's just 14 carry 1, 15 carry 1, okay, 0.9540. That's log of 9. Sorry, log of 9. Okay, hopefully you learned something from this tutorial, and thanks so much for watching.